Okay. All right, hello everyone. So if this is your first time here, welcome. Otherwise, welcome back. So today we are going to be jumping right in to content. So today we'll be covering Swift basics and as well as some like Xcode setup as well. So yeah. Also, reminder: if you haven't joined our EdSTEM already, here's the QR code real quick. If you guys haven't, most of you guys should be on there because I added everyone. So if you sign up for the course through the Google form, I've already added everyone on there to the EdSTEM, CMS, and the GitHub as well. So at the end of the class, if everyone isn't added, just double check that and I can fix that for you guys. Okay, just a few announcements. You could ignore the first one. There's no longer a roster form. We're just gonna base off of the Google form for the sign up. So if you haven't filled that out, please let me know at the end of class so I can add you to GitHub and stuff like that. And okay, so you have to have Xcode and GitHub set up ASAP because keep in mind, assignment 1 is going to be released later tonight. And for this assignment only, it will be submitted on CMS. Later assignments will be submitted through GitHub, just because this time we didn't really have enough time to cover a Git lecture because the curriculums that we just don't have enough time this semester. So for the first assignment, we will be using CMS. You can just directly zip your file and submit it on there rather than submitting on GitHub. But keep in mind for later assignments, you will want to know how to use Git because there's only submissions on GitHub. On CMS, you'll only submit a link to your GitHub. So keep that in mind. And office hours are out. They won't be happening this week. They'll be happening next week starting Monday. So keep in mind of that. So in case if you guys need help for A1, they'll be available next week starting Monday. And if you have like any issues enrolling on Student Center, please let us know. We don't know when we'll need like a course number or anything like that. But right now it seems like it's working. So please let us know if there's any like issues with enrollment. Okay, so I guess like a bit of a recap. So for those who watched the Git video already, this might look familiar. Otherwise, no worries. Just make sure you watch the video before A2 because you guys will need that for A2. A1, you're fine for now, but keep in mind you want to watch that Git tutorial for A2. So just to like sort of recap that, Git is a distributed version control system. Distributed as in it's distributed across multiple developers. You can use it at the same time. And version control as in you can control the version that you're using through a local repository so you can collaborate with other members of your team. So keep in mind, yes, Git is a software and GitHub is a service, and we will be using both in this course. And the process of uploading to a repository is to stage it by gitting add, and then committing by git commit, and then a commit message, and then git pushing, which pushes to the repository. And yeah, that just wraps about it. Any questions before we start with content? Okay, sounds good. Tiffany's going to start.
Cool beans. Hey guys, so today we're going to get started with some basic Swift syntax and concepts. So the first concepts we're going to kind of cover are variables and constants. So firstly, we're going to start with making sure you guys can set up Xcode Playground. So let me just tab over to Richie's Xcode. So I'm sure you guys should have Xcode downloaded by now. If not, you can head on to the the Mac App Store to install that. And once you have Xcode open, if you just hit File, New, and there should be this Playground option. So for this first lesson, we'll be using Playground, but in future lessons, we'll be making a project instead. But since we're only going over main syntax in this lecture, we'll kind of not be actually building any UI, so we won't need to actually create a Xcode project. So you just click Project, it will set that up for you, and yeah, so I'm gonna use Richie's preset up just so it loads quicker. Yep, there you go. Get rid of this. So this might take a bit to like properly get set up on your laptop, but no worries. I'm gonna start, I guess, with explaining a few concepts as we kind of dive into this. So firstly, for variables and constants, they're both made to store data. So you can kind of think of them as boxes holding a value. And the very distinct difference between these two concepts is that you're able to change what you define as a variable. And I guess on the other hand, constants are immutable, meaning that whatever you define as a constant, you're not able to change that. So for example, if I were to define my year, or like my birth year, I would define that as a constant because that's never going to change, right? Hopefully. So I guess how we actually go about defining these two concepts in Xcode, you use var to define a variable and you use let to define a constant. So let's take a look to see how that would look. So, for example, if I wanted to define an instructor variable, I could, there you go. define a variable with the keyword var instructor, and let's say I'm going to set this to Richie. So in this case, since variables are mutable, I'm able to directly modify what this box stores. So in this case, I'm going to change that to myself. And to run something on Xcode Playground, you can simply just click that little blue play button. And let's see if I can get this bigger. Ooh, okay. And give it a few seconds, and you should see the output will be on the right-hand side. So that's kind of how that works. And let's talk about defining a constant. So constants, just to reiterate, are things that you don't want to change. So for example, if I wanted to define my birth year, you define this with the let, since we don't want to be changing that. And I try to reassign this to, let's say, 2020, because I'm feeling a little old. Xcode will immediately yell at you and tell you that this is a let constant and you're not allowed to change it because it's immutable. So also, I don't know if you guys have noticed, the way I was defining variables here, I'm using camel case, which means that I define my first, it kind of looks like a camel-ish, but it's kind of a stretch, but I basically define my first word with a lowercase and my second words, I guess the following words with a capital case. So this might differ from, let's say if you take an 1110, I think Python would be like this, like with a underscore. So that's kind of the convention for Swift. So moving on to the next topic, let's cover data types. So you can kind of think of data types as describing kind of like the content in the box. So in this case, I defined two different data types, right? So the first one I defined was an instructor, and I made it basically a string. So in this case, it was Richie's name and then my name, and then following that, I defined an integer, which was the birth year. So in the variables and constants, we kind of are able to predefine, or you can choose to predefine them or define them afterwards, like what kind of, I guess, data type you want them to be. So Swift is statically typed, which means that for variables that we defined, we have to basically give it a type. So this kind of prevents us from putting any value inside of the box. So what this means is that if I wanted to, let's say, redefine this, let's do TA. So if I wanted to define a TA, and this is how you would define a type in Swift. So you basically do a colon and then a space. This is like the convention. So in this case, this TA is going to be a string because I want to define a name. So let's say I'll use Antoinette. And essentially what happens here is that I'm specifying that this TA variable has to be a string. So Xcode will get really mad if I try to make this like an integer. So if I run this, oh, I don't want to run it. There you go. So it gets super angry. And that's because we are not allowed to modify the type of a variable once we've defined it. So in this case, there's quite a few data types. If you head over to our course textbook, we go into a few more details on basically the rest of the possible data types in Swift. Any questions? Cool. So let's go into operators.
Okay. So as Tiffany mentioned, there's a lot of different data types in Swift, and with a lot of them, they have their own operators. So if you've taken any other CS course or learned any other language, you might be familiar with operators on numbers like plus, minus, multiplication, division, and modulo, which is essentially just remainder. So if you're familiar with those, great. It's basically the same thing as Swift. And keep in mind, in Swift, unlike a lot of languages like Python, is mainly an exception, I'd say. Operations can only occur on two number types of the same type. So you can only perform operations with ints by themselves, doubles by themselves. You can't really perform an operation on an int and a double. And there's also typecasting, which allows you to convert the type. If you want to sort of convert an int to a double in a double operation, then it allows you to do that. And last, probably the most important thing is it's string interpolation, which allows you to, rather than concatenation, it gives you a more intuitive way to sort of perform string concatenation. So I can directly show you guys here. Pulling up the Xcode again. Okay, so let me demonstrate some of the numbers. So let's say let's define a new variable. Let me just keep those. Variable called A. And then we can set that to 0. So obviously there's like, a is equal to a times 1, so that'll still be 0 actually. So just change number to 3. So you see that it's, normal. I'd say like I don't think I have to like demonstrate for each operation, but addition, subtraction, multiplication, division, and modulo work the same as any other language. Except, so let's say I wanted to define another variable b based on a, and they want to divide that a by, let's say, a double. So this, or float, sorry. So it's automatically give you an error here that it says you cannot apply the division operator from an int and a double. So in this case, you actually have to convert one of these types to a double by doing a typecast. So if you do that, it'll actually register for you. So essentially, variable b is a double. Actually, I can statically cast that, I believe. And there won't be any error. So b is a double. Therefore, in the operation of a, you have to convert a, which is an integer, to a double before you can divide by another double. So this is the one difference that Swift has over Python, is that you can't just divide any number, or JavaScript just has a number type. But Swift specifically, you have to cast between numbers in order to perform operations between them. So in addition to number operations, we also previously mentioned a strings as well, so with string interpolation. So you guys may be familiar with string concatenation. So we can do let name is equal to, let's say, even, just to keep it short. And then let's say you wanted to spell out the phrase, hello, my name is, and then you want to insert the name there. So you can do hello plus my plus name plus is plus name. So that seems, if you were to like concatenate that, it would, sort of spell it out as well. There's no spaces in it, so you'll see here. Yeah, it'll look like that, which is, it's right, but this is sort of, a lot of syntax just for like a basic concatenation. And in this case, let's say you wanted to actually change name to like age, and you wanted to make age a number. In this case, I believe it actually won't let you because, keep in mind, name, that should not work, hopefully. Okay, anyways, it shouldn't, but so in this case, we can actually use something called string interpolation. So rather than using the addition to concatenate strings, you can actually nest them in between the strings using this notation. So you can do hello, my name is, and then do a backslash, parentheses, and then put the name of your variable in there. So if you run that, hopefully that runs. So this doesn't really make sense, but keep in mind, so it sort of nested the variable age into the actual string itself. So rather than having to perform that concatenation by separating the string and inserting it, you could directly insert that variable or string into the string itself. So you could even move it to the center of the string. So normally you would have to concatenate by creating two separate strings and then adding them together. This time you can actually just directly put it in the middle of the string, and it should still work the same. So that saves you a lot of like time with like concatenation, and it's just a lot more clean compared to using concatenation normally. Okay, so it's not running, but yeah, trust me on that one. So in addition to those operators, there's also operators on Booleans. So these might be pretty familiar with like any other programming language. They are not similar to Python. Python is the one exception where and, or, and not are just different than any other language. But for like if you've done like Java or any other language, these are the basic operators on Booleans. I won't go into too much detail now, but there is more information on the textbook if you want more detail on that. Tiffany's going to go over data structures.
Yeah, no, I guess also to add on, if you take in Python or like 1110, I'd say like the way Richie was doing string interpolation just now was very similar to like I think it was called F strings. So basically you're sticking a variable inside a string, and that kind of just simplifies and makes your code look a lot cleaner. Okay, to kind of move on from that, I guess a bigger and more important part of Swift's syntax is the idea of data structures. So previously we learned how to store these values inside boxes we call variables, but in this case we want to kind of store them in something bigger and more complicated, because we kind of want to be able to access that data later on, whether that's holding, let's say, a list of Instagram posts, and like you can't technically store like let's say a whole entire list of posts in a simple variable structure. So in this case, let's first go over arrays. So you might be familiar with just the bracket notation, but essentially arrays allow you to store a group of values together in a single collection. And now the caveat with this is that the values that you store have to hold the same type. So for example, if I define a array of, if I define an array, at least if you define an array as a type, as a string array, you'll only be able to store strings in that array. So that kind of is a little bit, I guess, how that works. But I guess in more detail, if I can swap over to Xcode real quick. So if I define an array without a type, let's say I wanted to define a list of staff. So I guess for now we'll just have Richie, Tiffany, and Vin for now. So as you can see here, I'm using this bracket notation. I'm not defining this with the type so far, but if I wanted to, I could technically define this as a list of strings. So this colon notation always indicates that what comes after it is going to be essentially telling you what the type of this object is going to be. So in this case, it's a list of strings, and as you can see here, Xcode's not angry because I did indeed satisfy this and define it with a bunch of strings. So similar to a lot of other languages, you're able to basically access certain parts of the string. Swift is zero index, so your first variable is indexed with 0 and not 1. So if I were to run this real quick, you'll see that I did indeed get back the first variable of the array. I guess on top of this, another thing that we do with arrays is that we typically want to either remove items from them or add items to them, right? So in terms of like if you had a list of Instagram posts and someone posted something else, you want to be able to add that new post to your, your original list of posts. So how we can do that is simply with keyword append. So you take the first, the name of your list, and you just do .append, and you just put in whatever, new thing you want to add. So I guess in this case, I will add ant, and if I run this, I might have to put staff, just to show. You'll see that ant has now been added to the array. But I guess the important part is that since we define this as a list of strings, if I try to add the number 1, they'll get angry because it expects this to be strings, but you're giving it integer. So it's like, we can't do that here. And yeah, that's basically it for arrays. Any questions in terms of arrays? There's like a lot of nitpicky stuff, but we have more information on the course textbook if you want to get into like the more nitty-gritty stuff of how you can manipulate an array. Moving on, dictionaries, right? We all think of dictionaries as, in programming is that term where you're able to store key value pairs, but in a more general sense, they're like, this book where you can find a word and like see its definition. So if you've never heard of a dictionary before, you can kind of think of it like that. So in this case, the key and the value are stored so that if you index into a Swift dictionary with a key, you'll get back the value. So similar to, let's say, if you were looking up a definition of a word in a, Merriam-Webster dictionary, if you look for the word, array, with the key array, you get back the dictionary, the definition of the word as the value. That's a little confusing, but I think this will make more sense once I show you how that kind of looks. So, if I want to define a dictionary in Swift, this is like these two curly brackets is like the general syntax, but let's say I wanted to map the name of a staff member to their age. So in this case, we basically want to be able to input, let's say, like Tiffany's name, like my name, and then get back their age. So in this case, I want to define the type this way. So similarly, it's also kind of like a list of values, so you do want to use that notation. So first, I'm mapping a name. So let me do some comments here maybe. So I want to map, let's say, name to age, right? So I'm mapping a string value to an integer value. So that's kind of how that looks in terms of defining the type of the dictionary. As you can see, Swift is very type heavy, so a lot of times it will get angry if you don't give it the correct type. So let's kind of define this real quick. Just use this line. So let's start with my name, I guess. So the way I want to define this is with a colon notation. So this defines the key. So the key is Tiffany, and I want to define the age, right? So my age is 20. So this is the first value of our dictionary. So let's say I want to also define Richie's age. I could add a second element with the same syntax. You put the key, which is Richie, and you put Richie's age, which is
20.
Yay. And that's kind of how you initialize and define a dictionary to start with. Let me fix this space. And I guess the biggest part of what you want to do with a dictionary is that, like, when you have a dictionary, your intention is to find what a word means, right? So when I put in a key, I want to get the value back. So how you can do that is essentially just accessing it the same way you would access parts, I guess, of an array. So if I just put Tiffany here, I run this should return 20 because that's what I defined here. So as you can see, that's what it ends up doing. Any questions? No. Am I going too fast? Are you guys? Is this a good pace? Just let me know if I should slow down. Cool. I guess I hand it back to Richie for conditionals.
Yep, so I'm going to go over conditionals. So a lot of times you only want to execute code under a condition or apply control flow, as they call it, to your code. So this is where conditionals come in. So again, if you've taken any other programming course, you might be familiar with these, but I'll show you how these specifically work in Swift. So to check for multiple conditions, you can use the Boolean operators we discussed earlier. They're also in the course textbook since we didn't explicitly cover them. But this is and this is the or. So we can also chain if statements with an if else, and an else statement. So you can apply multiple conditions and check for multiple within your code. And we're not going to cover guard statements in this section. We're going to cover that a little bit later in a different slide. But for now, I can demo how an if and conditional statements work. Okay, so let me comment this out just for clarity. Okay, so let's say we have, let's define a variable called subteam. And then if subteam, so we can use the double equals operator to sort of indicate equality. So if we check for iOS, then in this case, we want to print then and then else if. So this applies a second statement. We want to check another condition. We can do, let's say, subteam again equal to design. And then we can apply that and print Liam. And then we can use an else condition. Let me just print person because there's a lot more subteams than that. Okay. So we let that. Okay, equals. Okay, so right now it's a blank string, so it'll just print person. So if we run that just now. Okay, so because the string is in iOS or design, it just goes directly into the else statement. And then let's say we were to type in iOS here and run it again. You can see that it'll print Vin. And the same thing if we put in design here, it'll go into that code statement and print Liam. So yeah, you can sort of see how the if statement works, or it allows you to sort of execute code based on a condition and sort of give you control flow within your code. So, you could chain a lot of these. You can add multiple conditions as well. So if you want to add a different condition, so we can add an or statement. Let's say Tiffany, which is also on iOS. Then we could also have the condition where if subteam is Vin is, sorry. You know what, that'll work. The logic doesn't really make sense. But if you make subteam Tiffany, also print Vin in this case, because you can sort of chain your conditionals using an or statement. Or if you wanted to and, you need to satisfy both conditions for that to print as well. So yeah, you can see because we typed in Tiffany, it satisfies one of the or statements, so it'll print the code under there. So as long as the if statement is satisfied, it'll execute whatever code is under that block. Okay, I think next we can go to Tiffany for loops.
So loops are basically another trick that, not trick, but basically it allows us to repeat code a certain number of times, which kind of, I guess, is a little implicit in the name loops, right? So there are two different types, as with most programming languages. The first of which is a for loop, and the second of which is a while loop. So if you want to iterate over something a certain number of times, let's say you want to print, you want to print like hello 10 times, then you'd use a for loop. I guess you could use a while loop, but it makes more sense to use a for loop because you know definitely that you want to print 10 times. So essentially these operators, I can show you guys later, but they allow you to print, like basically meet a condition, and it just keeps printing until that condition is met. So if we're iterating over an array, which we tend to do very often, so for example, I'm going to keep going back to Instagram, I guess. If I wanted to, for example, iterate over a list of posts and print those posts, I would use a for loop to kind of iterate through that list. And if I don't really know how long I'm going to be iterating for, let's say it could be 10 times, it could be 100 times. Let's say I'm waiting for a condition to be met without like any definite guarantee of when it'll stop. And you could use a while loop. So I guess for that, to make a little more sense, I'm going to pull up our handy dandy Xcode again. So I'm going to comment this out. So let's say we had let's define a list. So let's say, I'll just do staff again. Let's say, let's have Tiffany, Richie, and Vin, since we're all here. If I wanted to iterate over this list, there are two different ways. So as with most programming languages, I'd say you can either iterate by index or you can iterate by what's in the list. So more often than not, I guess I can by index, we can go over that real quick too. So if I wanted to go over basically a certain amount of indexes. So let's say I define this variable I, which is what I'll be using inside the for loop. And let's say I wanted to print this variable something 10 times. So this is the syntax. So that's 3 dots. Yep, that's 3 dots. And this will basically print from 1 all the way to 10. Does that kind of make sense? So this is how you define, like, I think it's like a range, I think in Python. This is how you basically print out from 1 to 10. So just show you guys how that kind of will work. Ooh. I print I right here. It will print there. I tripping. Or does it only for the last thing? Did I define I somewhere? Oh, is it because this shouldn't matter, right? Yeah. This one? Oh, there we go. Expand. Yep, so as you can see, we got the way a little bit, but we've successfully printed I 10 times. So like if you were to do this without this loop, you'd have to like basically type this 10 times, which is a little redundant, and I guess code redundancy is like something we want to avoid when we're programming. So I guess to actually use this array, let's say we want to loop over the staff members and print them out, right? So use a for loop again, since we're iterating to an array. And this second variable is kind of arbitrary. You could define it to be whatever you want. So I could say like for like chicken if I wanted to, but usually you want it to be something that you can recognize inside the for loop. So let's say I can say for a person maybe in staff. So this basically allows you to iterate over everything inside of this list up here. And we could do anything with this array, right? So but for now I'm just going to print it out. So if you can see, this variable that we defined up here can be used inside of here. So if I run this, it's going to print everything that's in the array. Okay. I guess something else that you might be interested in doing is, let's say you only wanted to print, or I guess, let's say you wanted to iterate through with using the index. Have you, like, I guess it's something that we sometimes do in Python if we don't actually care about the value of the array, but we actually just want, like, let's say an index I. So how you can do that is you also define I and 0. So you want to start at the first number I guess, first index of the array, and that goes all the way until staff.count. So staff.count is a function in Swift that returns how many items are in the list that you're basically calling count on. So in this case, it'll return 3. And if we try to print staff at I, it should do the same thing. So essentially what's going on here is that this staff, when you index I like this, it's essentially going 0. It's the first iteration, it's basically printing staff 0. The second iteration, it'll print staff index at 1 and 2 and 3, and so on. So as you can see, it prints the same thing because we're simply just indexing into the staff array here. Any questions? That was a little bit mouthful. Okay, so for while loops, essentially while loops are used for when you want to basically wait for a condition to be met. So let's say you don't know how many times, or I guess, let's say, okay, I guess we can also do the same thing we did here, but with a while loop. So in this case, let me move this down so we can kind of see it. We printed I 10 times. So to kind of define the same thing, the same functionality, using a while loop, you can define a starting index variable, I, as 0. So while, this is the syntax, while I is less than 10, you can print I. So essentially, this loop will continuously run until this initial condition is met. So do you guys think, can someone tell me if you guys think this will print 1 to 9 or 1 to 10? Yeah, exactly. So does everyone kind of get why that is? So basically, when, I need to increment this. So that's a big part of, Big part of while loops is that whatever counter variable you're using, you have to make sure you increment this, or else you get stuck in this loop forever, and that will not be good. So basically what happened here was that when we increment until 9, this loop will not run again, because, until 10. After it prints 9, you get to this last iteration where I is 10, but 10 is not less than 10, so it stops printing. So I can kind of show you that real quick. Let's do work. Did the whole thing restart itself?
This is launching still.
Oh, okay. I think it's fine. Maybe we can go. Oh, yeah. There you go. So it prints 0 all the way to 9 in this case, because at 10 it didn't meet the condition anymore, so it broke out of the while loop. And I guess another important thing is that if you want to break out of a while loop early, so let's say you want to break when a certain condition is met. So in this case, let's say if I equals, let's say 5, and you want to break, essentially when you call break here, it cuts out the loop at exactly this point. So nothing after this point will run. So if I run this, it only stops at 5, because at iteration 5, we got a break call, and that basically takes us out of this while loop, and we're done with the loop. So yeah, any questions again? Just kind of also a bit.
Okay, so as Tiffany demonstrated with for loops, code reuse is a very important part of coding. So like in any large-scale application, there's going to be thousands and thousands of lines of code. So anywhere you can, you want to save as much code as possible. So one of the biggest ways to do that is with repetitive code, you can define a function. So in Swift, to define a function, you use the func keyword, and you can also specify a return type using the arrow. And like any other language, you can also specify arguments and pass parameters to those as well. So let me just quickly demo that for you guys. Let's comment these out. Okay, so let's just define a simple function. So we're going to use the keyword func. Let's say my name, and then we can just do print. Hello, my name is. So yeah, if you wanted to sort of call this function, you would just do the name of the function followed by print. And keep in mind, Xcode has auto-completion, so you can directly press enter on any of these and it'll autofill for you. So if you run that, it should print whatever statement there. Yep, exactly. So let's say you didn't want to print my name every single time. You wanted to input a name and add a parameter, as we call it, or an argument. So we can specify the argument name by using whatever name you want and a colon. So it doesn't have to be the word name. It could be literally anything you want. It can be S, it can be A. To specify a name for an argument. And you have to also specify the type you want. So in this case, we want a string because we want to input the name as a string. So keep in mind now we're sort of missing arguments. You can see here. Actually, there's a really cool feature of Xcode where you can auto-fix it. So we can automatically fix it for you, and it'll put the code chunk in there for you. So let's say we actually wanted to input bin here. And then we want to use this parameter as well. So we can go back to string interpolation before and actually input the name here. So we're referencing the name here in the arguments in the actual print statement. So now we can actually input a argument into it. So let's say you wanted to print different names. So let's do Tiffany. So as you can see, you can use the same function and use a different argument and pass a different parameter to an argument, and it'll do the same. So you can see in this function, there is no return statement. Right now, it's just a non-fruitful function. It merely executes an action. It doesn't return anything. So if you want your function to actually return anything, you want to use a return statement as well as specify a return type. So let's define a new function here called getSubteamLead. So get the subteam lead. Let's define a argument called subteam, and then we want subteam to be a string. And in this case, we want to actually return something. So given the subteam, we want to return the subteam lead's name. So we want to return a type of string. So that'll actually specify that the return type will be string. And automatically, you'll sort of get this error after everything settles down that you're missing a return type. So it's expecting a return type here, string, but you're not actually returning anything. So just to silence that for now, we can just return the empty string. Okay, so as you can see there, and let's just go back and take this code here. Take this, put it in there, and just put this above here. Okay, and let's just add a few more subteams. So let's say else if subteam equal design. Where's it? Marketing. Print. Jane. Else if subteam equal Android. Print. Justin. Okay, and then actually, so rather than using the print here, we actually want to return now, because we want our function to actually return something. So if you are going to use conditional statements, make sure that each conditional is returning something if your function is fruitful. And they all have to be of the same type. So if one of your conditionals does not return a string, it'll actually give you an error that you're not having the right return type. So let's just do that. So make sure you have full coverage of everything, and we can just add the empty string at the end, just in case. Okay, so now if we get subteam lead, now we're actually returning a value, so it won't actually print anything in the terminal here. You'll probably most likely see it on the side here. So let's say we wanted to print iOS. And if we run that now, it just should say bin on the side here. Yep, so it is returning bin. If we want to specify design now, now it should return Liam. And if we give it like any other string that's not specified, it should just skip all of the if-else's and just return the empty string like so. So yeah, so that is an example of a fruitful function, and that should cover most of what we're going to do with functions in this class. Okay, so probably one of the more important topics that we're going to cover in this lecture is optionals. So does anyone here have an idea what an optional may be? Nope. Okay, so an optional are types that can hold nil or null, as in other languages, or none in Python. There's different ways to say it, but essentially the existence of a non-type, so no value existent. So optionals can hold that value or an actual number. So you can indicate an optional using a question mark. So if something could be a string, or it could be nil or none, in Swift it's nil. But if you have that sort of distinction where it may be a string or it may be none, you can put the question mark behind the type of any return type or parameter type, and it'll specify it as a string optional. So it could either be a string or it could be an optional. So, these are useful because sometimes you don't know if you always have a value. Let's say you're fetching something from an API. You won't necessarily get that value. You may get something that's none value or a nil value. Okay, so what we can do here is actually modify our existing function. So let's say, if we didn't get any of these values, let's just say we want to return nil here, represent the none type. Because if none of these subtypes fit, think I'm forgetting back end. Okay, so we have that. So in this case, if none of these conditions are met, we actually want to return nil. And you can see here we have an incompatible type with nil and string. That's because we haven't specified that our return value is optional. So meaning our function can return a string, or it can return nil as down here. So how we want to distinguish that is actually go back to this return type up here and specify that we can return an optional string, meaning that you can either return nil or you can return a string. So if any of these conditions are met, it'll return a string. Otherwise, it will return a nil value. So let me demonstrate that real quick. So we can autocomplete that. If we do iOS, it'll give Vin. Let's say we want to do something else called cool, the cool subteam. So if we run those both, you'll see that one returns an actual value listed here, Vin, and you can see that the other one returns nil. So that is because none of these conditions are met, therefore it just skips directly to this last return statement and gives you a nil. So let's say you actually wanted to use this value. So let's get this function back down here. So let's say you wanted to print the name. And let's say you have team subteam lead is equal to, and then we'll call this. So keep in mind, this is now also an optional value because the return type of the function you're calling is optional, therefore this is also optional. So if we do string and not specify that it's optional, this will actually give us an error because now it's asking, this is an optional string, not an actual string. There may not be a string here. So if you actually click this button here, it gives you a bunch of options that you can do. So you can actually just force it, meaning that if it's not a string, you don't care. You'll just go far anyways. And this will actually cause a lot of errors. So if it's a nil and you force it and you want a string, it'll essentially crash your entire program. So you actually never want to use the exclamation point because this is just bad in general. I guess there's some cases in emergency if you want to use it, but mainly never really use that operator. There's also coalescing with the question mark, which allows you to give a default value. So if it is not any of the strings, it'll actually give you a default value. So we can say default, we can call that default. And then, so yeah, if we don't say iOS, let's say it's some random value here, you'll see that despite it being nil, it'll just give you the default value or whatever string you want to specify here. You can set the default value to sort of, make whatever nil value into that string in the case that you have something that's none. Another way that you can do this is if you wanted to use a if-let or a guard-let. So we sort of mentioned the guard-let before, but I can sort of demo that now. Okay, so let's say you wanted to call the function myName, and your subteam lead is optional, so we won't actually enforce this. So right now, the constant subteam lead is an optional string, meaning it can be string or it can be null. So let's actually see if we can call the function myName on. So myName prints out the name of the subteam lead. So if we input subteam lead here, you'll see that we'll actually get an error because, again, it wants an actual string when we have an optional string. So one way you can do this without using an optional value or like a default value or forcing it is you can use an if-let statement. So let's say if-let name is equal to subteam lead. So essentially you are unwrapping this optional value here. And now you can use the variable name in myName. So you can call myName and use this keyword name here. Okay, let's kind of just call that name too. So what you're essentially doing here is you're unwrapping subteam lead, which is an optional string, into the other variable that you're defining here called name2. And then if that is not nil, it'll actually call myName, and you can specify else. You can have it print a nil value. Okay, so in the case here, we have that subteam lead is a nil value. So if you run that, it should print nil value. Hopefully.
Does anyone have any questions on options? I feel like they're the most, confusing concept, in this lecture. Usually people don't really understand, their point. Yeah, what's up?
Is nil just the equivalent in Swift of null?
Yeah, null, none.
Yeah, whatever language. It's the non-value. There's no value, therefore it's nil, or none, or null, whatever other languages use. It's a similar thing. So you can see that it printed nil value, meaning that this value was nil because this subteam does not exist. So let's say we change that to iOS. So subteam lead is now iOS, and we're unwrapping that subteam lead variable into name2. It should now actually run the myname function because it receives that name is. Okay, actually, let me just remove those so it's not confusing. Right, so now that subteam lead is actually a value because it'll return vin, it'll actually run the function properly and call whatever's in that if let block. So if whatever here is not nil, it will run this block. Otherwise, it will run this block. So this sort of allows you to control your statement as well, control your code in terms of figuring out if your a value is null or not. You'll have it perform one option versus the other. So another option where you can do this with is using a guard let statement. So it's sort of the same idea, but you can sort of think of this as like a shield that prevents any further code execution if the value is nil. So let me just get rid of this for now, or comment it out. So guard let, we can do name2 again, is equal to subteam lead. And then you want to specify an else condition, print nil value. Okay, so if you see here, let's just specify a value here so we know that it finishes running. And then in a guard body, you always want to return because if you do receive I think I'm gonna break in this case. Let's break. Okay. I think it's throw. Essentially, any way you can exit out of a guard body, so either whether that being throwing an error or returning. In this case, it's in a playground, so it won't actually just let you straight up return, but just pretend that it will. Essentially, what this does is it's the same idea as an if let, except if this condition is not satisfied. Okay, wait, yeah, I don't think we should do that. So essentially, it's the same idea as the if let, except if this condition is satisfied, it actually skips all other code afterwards, stops execution, and does whatever is under this block here. So it's sort of the opposite. So if in the if let, it has it so where if this condition is satisfied, it continues with this, otherwise it continues with this. In the guard let, it sort of guards the code from any nil values by stopping execution and executing this block here if this value is nil. Otherwise, it proceeds as normal and it would print cool. So let's say, if name2, if subteam lead was a nil value, it would just print nil value. Otherwise, it would proceed with the code as if nothing happened and print the word cool. So essentially, you could think of a guard as sort of a shield to prevent future code from encountering any nil values. Okay, so whoopsie. Any questions? I know that was a lot. It's probably one of the harder topics that we covered this lecture. Good? Okay. Okay, so we're going to take attendance with the Kahoot. So put the Kahoot here.